This content is AI generated for informational purposes only and should not be directly used for clinical decision-making.
Hello and welcome back to the Neurosurgery Hub podcast. I'm Dr. Aris, Senior Attending Neurosurgeon, and I'm joined as always by our research fellow.
And I'm Dr. Alara. Today we're looking at a fascinating new study from Science Advances, published in February 2026, titled Causal Parametric Language Mapping with Electrical Stimulation During Awake Neurosurgery.
This is a heavy-hitter paper, Alara. We're looking at a massive collaborative effort involving Carnegie Mellon, the University of Pittsburgh, Rochester, Albany, and several other top-tier institutions. The lead author is J. Ralph Belkier, with senior oversight from Bradford Mahan and Jorge Gonzalez Martinez. For our residents listening, these are the names you see at the forefront of cognitive neurosurgery and awake mapping.
Exactly. And the reason this paper is making waves is that it addresses a fundamental limitation in how we've been doing awake craniotomies for decades. Traditionally, we've relied on direct electrical stimulation, or DES, as the gold standard for mapping. But as you know, Dr. Aris, our clinical assessment of that stimulation has historically been quite binary.
Right. In the OR, we usually look for a hit or a miss. I stimulate a site in the inferior frontal gyrus or the superior temporal gyrus, and I'm looking for speech arrest, anomia, or maybe a clear semantic paraphasia. If the patient stops talking, I mark it as eloquent. If they keep talking, we move on. It's very qualitative.
And that's exactly what this study, Causal Parametric Language Mapping, seeks to evolve. The authors argue that by treating language disruption as a binary state, we are losing a wealth of data about the actual functional architecture of the brain. They moved towards a parametric approach. Instead of just arrest versus no arrest, they looked at how stimulation causes a gradient of change in language performance.
Let's dive into that. When they say causal, they are leaning into the unique power of DES. Unlike fMRI or MEG, which are correlational, showing us what's active during a task, DES allows us to temporarily lesion a specific coordinate. It proves that a specific node is necessary for the task. But what does the parametric part look like in practice during a 4-hour awake case?
It's about the sensitivity of the behavioral measures. The researchers used a sophisticated experimental design where they didn't just listen for a gross error. They measured specific linguistic parameters. This allowed them to map language not as a series of isolated buttons that turn speech off, but as a continuous landscape where different areas contribute to different degrees to things like phonological processing or semantic retrieval.
It's interesting you mention the multi-center nature of this. Looking at the author list, Garcia, Malala, Pease, Gonzalez-Martinez, you see a mix of high-volume surgeons and cognitive scientists. This paper reflects a move towards quantitative awake mapping. For the residents listening, think about how we use motor evoked potentials, or MEPs, or somatosensory evoked potentials, or SSEPs. Those are quantitative. We look at amplitudes and latencies. This study is essentially trying to bring that level of rigor to the softer science of language mapping.
Right. One of the key aspects the paper highlights is the use of electrical stimulation to probe the causal relationship between specific cortical sites and the complexity of the language task. By varying the linguistic load, the parameters of the words the patient is producing, they can see how stimulation interacts with the brain's ability to process information.
I want to focus on the causal part of the title for a second. We often talk about eloquent cortex as if it's a fixed map. But we know from experience that patients can sometimes tolerate a resection in an area that showed a weak hit during mapping. This paper suggests that by using a parametric approach, we can better distinguish between a critical node and a participatory node.
Exactly. And for the practicing neurosurgeons tuned in, this has massive implications for the maximal safe resection philosophy, especially in low-grade gliomas. If we understand the parametric drop-off in function, we might be able to push the boundaries of a resection more safely than if we just see a single speech hesitation and stop everything.
It's also about the technology. The paper mentions mind trace technologies and several software-heavy methodologies. We're moving away from a surgeon just saying number 4 is Broca's, and towards digital integration where the stimulation parameters and the patient's vocal response are analyzed in real time.
The study emphasizes that this isn't just about avoiding a permanent aphasia, it's about preserving the quality of language. We've all had patients who, post-operatively, technically pass a bedside language exam, but they tell us they just don't feel as sharp or they struggle with word finding in high-stress situations. This parametric mapping is designed to catch those subtle deficits that a simple repeat the word apple task would miss.
Let's look at the mapping part of the title. Usually, mapping is a snapshot in time, but this study looks at it through a lens of causal parametric language mapping, which suggests a more dynamic model. Dr. Alara, did the paper touch on how they manage these stimulation parameters themselves?
Yes, they were very specific about the methodology of the electrical stimulation. It's not just about the milliamps, it's about how the stimulation interacts with the cognitive architecture. They used it as a tool to test hypotheses about how language is organized. Because it's causal, when they stimulate and see a parametric shift in, say, reaction time or phonemic accuracy, they can be certain that the stimulated site is an integral part of that specific linguistic circuit.
This is a shift in the standard of care conversation. If this research from Belkir and Mahan becomes the new norm, the gold standard of DES won't just be about the bipolar probe and a stimulator box, it will be about the integrated linguistic task. We're talking about a more bespoke awake mapping session, tailored to the specific connectivity of the patient's tumor.
And that's a great point for the medical students. Neurosurgery isn't just about the how of the surgery, it's about the where and why. This paper shows that the where is much more nuanced than the classic Penfield maps we see in textbooks.
It's worth noting the 2026 date. This is the cutting edge. When you look at the involvement of institutions like the University of Pennsylvania and the University of Rochester, you see that the field is moving towards a highly collaborative, data-driven approach to the OR. They are turning the operating room into a high-fidelity laboratory without compromising patient safety. In fact, they're doing it to improve safety.
One final thought on the causal aspect. The authors really hammer home that this methodology allows for a finer triage of brain tissue. In the past, we might have avoided an entire gyrus because of one positive stimulation site. This parametric approach might show us that only a 1 centimeter subregion is truly causal for the primary function, while the surrounding area is part of a more resilient distributed network.
It's about moving from a static view of the brain to a functional network view, but with the added rigor of direct causal intervention. This is causal parametric language mapping in a nutshell. It's about the gradient, not just the cliff.
Precisely. It's a fascinating read for anyone interested in the intersection of linguistics, neuro-oncology, and physiology.
Well, that's all the time we have for this deep dive. A big thank you to Belkir, Mahan, and the whole multi-institutional team for this contribution to Science Advances. For our listeners, we highly recommend pulling the full text to look at the specific parametric models they used.
Thanks for joining us. We'll see you in the next episode of the Neurosurgery Hub podcast.
Keep operating and keep learning. Goodbye.